Hello guys, welcome back to my YouTube channel. Hello, my name is Melanie Putri. In this video, we will the voice about chemical environment. The first, um, the sample strategy. The sampling strategy is collecting a constant volume of a water body to be studied with the smallest possible amount, but still representative and still has all the same characteristics as the water body. For example, taking sample of seawater, lake water, and extension. This strategy is very important because the sample with it is taken and after is it used the volume must remain the same so that this can be called valid data. Sampling is divided into the following three steps. The first, reflexive sampling. Second, transport and preservation of sample. And the third, chemical analysis of the sample. All the test parameters can be physical or chemical parameter or both of them. Now, preparation of sampling and preparation. The bubble that will be used to take the sample must be clean and have been frozen with disinfected water and disinfected water first, then followed by the liquid that will be used to fill the water and dry, if possible. Make sure the bottle does not contain any contaminants from the previous analysis. This is because the concentration of the analysis is very small, so there should be no trace of contamination from the previous analysis. The same applies to sample equipment such as PFAS pump and bench, which must be clean and free from residues from the old sample, especially the crown of mold and mildew must be prevented because these fungus can absorb or reduce the thing we want to test. Contamination from metal or sampling equipment, which may dissolve in the sample, must be prevented. Fifth, iron brass rust can dissolve in water that is acidic or basic, so the metal must be considered. While plastic and rubber material can dissolve in industrial water containing organic soap or oil and gasoline. For example, do not close container made of plastic or rubber if the sample contains organic or non-polar material. The sample can be taken separately, use a bucket, plastic or glass bottle, open and heavy, for example, with a lid ring around the mix. Feed with a rope, then put into a river canal well and so on. Sampling strategy. The one taking sample at certain depth. Provide a closed bottle that can be opened then is faces the desired depth. To do another way is to use a can of sucking pump. Entry sample from water outlet can be taken with an open beaker or a bottle to be closed, depending on the analysis plan. And using the automatic sample, which is a special tool to take sample in succession. Now, disturbance that might arise during storm and transport of sample. Cases such as O- Oxygen and carbon oxygen can be absorbed by the sample water or can be sampled from the sample water into the air. Suspended and colloidal substance can from their own cause sample becomes different from the state when it was tested. The same method of sample preparation. It begins of the analysis to be carried out and the element to be investigation. The two, analyte contamination. Air analyze or compound or sample that exist the environment that need several things that need to be considered so that the data we get early is said to be false or the data we get later is expected to be representative of the same as the actual condition that exists in our environment. Contamination is defined as the entry of unwanted compound into our sample during the initial process of the sample of tearing with the source of contamination is the sample can come from the operator of the equipment, from the eye, or from the analysis of contamination from the atmosphere. Mainly more particle elements on the soil surface are suspended. Material that is the atmosphere. So for example, we understand that in our atmosphere there is still or in the form of aerosol, namely small particles floating in the air which can also contaminate our analyte because our analytes usually have very small concentration. So we have to be careful. Be careful not to become more concentration and is not the same as the actual condition. We must avoid. To avoid atmosphere contamination of the sample is to close the sample solution during the preparation and subsequent analysis process. If analytical is a material compound of parameter that we want to study, we want to see the level, it's called temporary analyte, the person who measures it. The analyte and analytes can be a source of contamination to the sample which will either through their contact or through eye the loss or contamination of an analyst can affect what data the products. The concentration can decide of even increase which we call contamination or increase from the actual condition. For example, from our breathing, from our breath can be detection that can move into the analyte. An example is smoke or cigarettes carried out by analysts, for example, which is a source of contamination in this metal. Maybe it seems impossible for all the chemical analysts would later work in the laboratory while smoking. This is certainly not allowed because later there will be flammable Reagen. This is very dangerous when working condition and everything that is not related. For example, contamination is of cigarette analytics. The analyte used by an analyst is perform lotion powder which can provide certain level, including cloth and shoe operator, which can be a sort of contamination. What we use must be clean, and there are other additions. Human skin is sported to contain some metal with very low concentration, but the one we tested early was in low contraction, so we have to take care that our analyte concentration does not then increase because what is transferred from use to the material we are testing next is a laboratory closed mass. Think that this contamination of analyte, the contamination of this equipment often occurs both in equipment made of glass made of rubber and the net for clear glass in Reagen. Glass fuse mean porous glass such as pirate. The glass in the chemistry lab or used by analysts is usually a silicate glass such as pirate analytes. Otherwise, not contamination of the sample from the glass is usually caused by attack or dissolution of the contamination by the solution, namely by this glass solution. For example, the material used is very strong side, or the halogen group, for example, is HF. How to anticipate contamination for contamination? Now, from container, for example, by washing the glass unsealed using H2SO4 and HNO3. This means that it is not important, but is diluted first and used to wash usually. This is usually used to soak the glassware that you want to use. And the next, sources of contamination. The key is three. The first is contamination from the atmosphere, contamination for analyte operator, and contamination for equipment. Now, contamination from the atmosphere is derived from particles, great element of the soil surface, and suspend material in the atmosphere. The simple way to avoid atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. In the contamination for analysis operator can be a source of contamination of the sample to be analyzed either through direct contact or through the air. Example, NaNC, a powder lotion, perfume, clothes, sauce, and extension. The glass, parasite, contamination for equipment. One of them is glass. Physical glass such as ferrite are commonly used in the analytical chemistry. Contamination of the sample from the glass is caused by the effect of the container by the solution. The glass used is the sample must be adjacent to the solution used. Ferrite is resistant to weak acid and base, but less resistant to strong acid and base. Anticipating contamination containers, washing soaking. Glass water used is mixture of H2SO4 and HNO3. Dilute solution in a ratio of 1:1. And the three, analyte contamination. Analyte contamination, what can affect the contraction of the analyte in the contamination of the reagent, which can provide additional concentration. Contamination from reagent is divided into 5 groups, including mineral oxide and ammonia, due to inorganic solid, reagent anorganic, and solvent organic. Mineral oxide and ammonia. Most mineral oxide contain certain amount of metal. There is a pure Acid contain very low level of metal and the generic with expensive, and ultra pure generally contain a fairly low metal content, but from on one product to another the content of several elements varies. Analyte reagent grade aside, which usually contain the metal listed in the table. The ammonia monomer solution in water if placed in a glass bottle will be contamination by silica, aluminum, calcium, and the other element, which may be caused by effect of alkaline solution on the glass. Inorganic solids. This solid with reagents quality is usually pure enough to be used directly without purification, but a plain solution must be prepared as a control. Lead PB is an important metal which purification is usually done by crystallization or filtration. And the three reagent organic. It usually contains a coordinately bound metal, which is usually derived from solvent or reagent used in the synthesis of reagent. These reagents are usually used in small quantities, and their contamination can often be neglected, but caution is required. And the last, solvent organic. In organic solvent, there is usually a relatively low metal content, which needs to be watched out for is the presence of other organic compounds dissolved in the solvent, and this can interfere with the spectrometric determination. Plus, analytic can be caused by factors including absorption, volatilization, and also complexity. Okay, guys, thank you for watching, and I hope I'm apologies about my material, and thank you for watching. Don't forget to like, subscribe, and stay tuned in my YouTube channel. Bye bye. Assalamualaikum warahmatullahi wabarakatuh.